All right, let's just go through the story here. So f of x is equal to root of 6 minus 4x. I can tell you the domain and range of this thing. It's not a difficult one. The range is going to be f of x is greater than or equal to 0. And the domain of it is when 6 minus 4x is greater than or equal to 0. And that occurs when x is less than or equal to 3 over 2. Relatively simple. Again, you may need paper and pencil to do that. And then I want to go through this inverse part. I'm going to call the inverse, they're calling it g of x, so I'll call it g of x. So g of x is actually the inverse of f. Right, I'll write this over here, domain and the range. The domain is going to be x greater than or equal to 0. And the range of it, I'll just put down g of x, by the way. The g of x has to be less than or equal to 3 over 2. All right? So what am I going to do now? I'm going to do it. And how do you do that? I'm going to, what I did in 119, I'll just write this over here. Square both sides. Oops, sorry about that. I'm missing a step. I want to be consistent. X, 6 minus 4y. Square both sides, you get x squared. Then what do you get 6 minus 4y. And then, I'm going to add 4y to both sides and subtract x squared from both sides. Then what do you get there? Let's take a look. You get y equals 6 minus x squared over 4. I'll write that down now. I know the inverse. All right, let me get my eraser out. I'm going to kind of erase evidence of my Math 119 work over here. So this is important. I got this information down here. Now again, I'll certainly read through that, but what I want to do is, use this theorem, and we'll talk about it in a second, to calculate g prime. I think I can do g prime right now, right? I'll write that down for you. What's g prime going to be? G prime is going to be, minus 2x over 4, which is going to be minus x over 2. Again, with the understanding that x is greater than or equal to 0. All right? So, let me take a look at this. What I'm going to do is use that theorem they're asking me to do. And that theorem's right over here. All right, let's take a look at that. 35, assuming that fx differentiable 1 to 1, got an inverse, belong, blah, domain, blah, blah. Yeah, stuff that we talked about. And then let's write it down. Right, we know the derivative. By the way, I think there's an error in my notes over here. And this should be greater than or equal to 0, by the way. However, let me think about that before I commit to that. And you know what? You're right about this is correct, but the derivatives can't be left or right of that. So I'm going to say it's true. The x must be greater than 0 for that to be the derivative, because there is no derivative at 0, by the way. Okay, what am I going to do now? Let's put it down. We're going to put g prime of x down. I'm going to use that theorem 35. It's going to be 1 over f prime evaluated at g of x. Let's put this down. It's going to be 1 over. What's f prime? I didn't write that down, did I? So let's write that down. F prime is going to be 1 over 2 square root 6 minus 4x, and on top of minus 4. So, f prime is just simply minus 2 over the square root 6 minus 4x. All right? That's not too bad. And let's write that down. And what do I got to do? I got to evaluate f prime at g. And this is what g is over here. Let me write that down for you. Minus 2, right? Divide by square root. Gotta be careful here, don't I? And what do you get there? Well, 4 times this thing over here is going to be 6 minus x squared. So you're just going to get x squared. Wow, that looks really strange, doesn't it? Let's keep going on. And what do you get there? You're going to get the square root of x squared over minus 2, which is going to give us, and again, you got to consider this x is something. The x is greater than 0, right? So this would be x, if it's greater than 0, over minus 2, or minus x over 2. Right, is that what we're getting? It's what we're getting, all right? Again, my gut feeling about this over here, it can't hurt to understand what we just did over here, but I will say this, though. It's not bad finding inverses. The problem is I can't always find an inverse. Right, it's not very difficult, but I may know the function's invertible, though. All right, thank you.